Now that we know how to evaluate piecewise to function, let's graph one. So we have the function f is defined as f of x equals, and we have two functions. We're going to use x minus 1 when x is less than or equal to 2. And we're going to use x squared if x is greater than 2. So we need to kind of make a table of values for both of these functions. So we have f of x or y equals x plus or x minus 1. And we'll make a table. And then I'm going to make a table for y equals x squared. As well. Now, there is a really big number here that we need to make sure is in both of our tables. As you can see, we have a graph when x is less than 2 and a graph when x is greater than 2. So right here, I'm going to make some dashed lines. Here is where my graph is going to change, right? So to the left of 2, I'm going to have this linear equation of x minus 1. And then when x is greater than 2, I'm going to have this quadratic function, which is going to make that U-shaped parabola. So because it is so important about this break right here, we need to know where these values are going to end and start at this break. So both of these functions need to have a 2 in it. We need to know what happens when it changes from linear over here to then quadratic. Okay, now there's several things that kind of need to happen, and it doesn't really matter the order you do these in. So first, let's talk about open and closed circles real quick. Because on this first one here, x is less than or equal to 2, at this 2 here, we need to make sure that we have a nice solid point. Here, x is greater than 2, but does not equal it. So here we're going to have an open circle on our graph. We also need at least one other point in this table other than what's happening at this breaking line. So if this one here is when x is less than 2, what is a number over here that is less than 2? The next logical one would be 1. Now, if you want to plug in more things, you can plug in more values here. We could do 0 and -1. You could do -2, but I'm out of room. You can do as many as you want, but you need at least where this breaks and one other point that's in this domain. I can't put 3, 4, and 5 over here because it's when x is less than or equal to 2, and 4, 5, and 2, or 4, 5, and 6, or whatever I said, is not that. Okay, hopefully that makes sense and I'm not just rambling here, but okay. So now let's graph this portion of my graph. Let's plug in these values here. So we're going to have, when I plug in a 2, 2 minus 1 is 1. 1 minus 1 is 0. That's at minimum what we need. But if we keep going, 0 minus 1 is -1. And -1 minus 1 is -2. So let's plot these points. So I am going to put a nice bold point right here at 2, 1. Okay, and I'm putting this in red just to make it more clear and pop a little bit more, but you don't have to do this in a different color. And I'm going to plot these other points, and these are all just regular points. So 1, 0, 1, -1, -1, -2. So when we do this, we're going to start at this breaking point or at that bold, different colored red circle and go through the rest of these. So I'm going to start in that circle and go through the rest of them. So that's what the left side looks like. Which, if we know our y equals mx plus b, this should all make sense. These all have a slope of 1. We're going up 1 over 1, up 1 over 1. And it has that y-intercept right here at -1. Okay, so now let's evaluate this side here to figure out what's going on the right side of this. So again, we have to have that 2. We need to know what's happening on this breaking line. Then I need something else in the domain. If x must be greater than 2, the next logical point would be 3. Now we can add more points, but even this 3 is not going to fit on our graph, so I'm just going to do these 2 here. So when I plug in 2, 2 squared is 4. And when I plug in 3, 3 squared is 9. Okay, so I'm going to plot 2, 4 with a nice open circle. And then if I could, I would plot 3, 9. So 3, we're just going to pretend that's 5, 6, 7, 8, 9-ish. And because this is a quadratic, it needs to be a parabola, meaning a U shape. So this shouldn't be a straight line. This should have a tiny curve through it if you can do that. Okay, so here is my graph. Now we need to state the domain and the range of this graph. Domain. As I go from the left to the right, the first thing I touch is this arrow. So we're going negative infinity to. Now, as I keep going, I don't have a break on this domain. I don't have a break, even though there is a break along my y's. There is not a break along these x values, right? We have an x value at -1, at 0, at 1, at 2. We have the solid points. We at least have a value at 2. And then at 3, we have a point. At 4, we would eventually have a point. At 5, we would eventually have a point. So this arrow tells me to infinity. Now my range will be different. As we go from the bottom to the top, talking about these y values here, we do have a break in those y's. So this bottom portion here will be negative infinity all the way to, we have a y value right here at 1. And that 1 is a closed solid circle, so we have a bracket. And then the union, then let's talk about this top portion here. The lowest number here is at 4, but because it's an open circle, that will be parentheses 4, and then arrow to infinity. Now, intercepts. I don't think on your homework it asks for x and y intercepts specifically, but since we struggle with intercepts, I wanted to break them down a little bit more. So x-intercepts, where is this graph crossing my x-axis? And it's crossing right here at 1, 0. And then y-intercepts, where is it crossing this y axis at here? And that's at 0, -1. Now, the last thing it's going to ask is if f, your function, is continuous on its domain. So what does continuous mean? Here's your definition for a continuous function. It says a function is continuous if its graph has no gaps or holes, and I guess maybe what we should have only underlined, can be traced without lifting the pencil from the paper on which the graph is drawn. It does not matter that this domain is all real numbers. Can you graph this with one pencil stroke? And no, you would have to graph this, then you would have to lift your pencil to jump up here to graph the rest of this. So this is not continuous. Now, rewatch this video if you need to, and then I want you to pause it, and I want you to try to do example 3 on your own. Okay, so I hope you have paused this video. let's walk through example 3. Okay, I have already done this one. So first thing we need to do is to make a table. So I have listed my y equals negative x and my y equals 3x minus 1. This graph, unlike this one, which was breaking here at 2, so we included 2 on both of these. This one is breaking at 1. So these ones need to be the first one in my graph because this is where this graph is going to break. It's going to look different on the left as it does on the right of x equals 1. Then I needed to put another point that was within its domain. So because this one is when x is less than 1, the next logical one is 0. This is the minimum amount that you need. You can do -1, -2, -3, and so on, but you need at least where it breaks and one other one in its domain. So when I plug in those in, we get 1, 2. So I plotted that originally with an open circle, and then we have -0, 3, and I drew it from the red one or from the breaking through the second one. Then at 1, we are at 2, and then 1 more in its domain. So x is greater than or equal to 1. The next logical number that is greater than 1 is 2. Again, you can do 3, 4, and 5, but you have to have at least one other one. So then we went to plot it, and we should have taken this open circle and then just filled it in. And then 2, 5. So we went from the red circle or from where it breaks through that next point. So here is our graph. So what is the domain? Okay, if you didn't graph this on your own, pause it, write that down, graph it, try to fill out B, C, and D, pause the video, try to do it on your own, and then let's hit play and let's check our answers. B wants to know the domain. So as we go from left to right, we're going from arrow to arrow with no breaks on those x values. So that is -infinity to infinity. And then our range, as we go from the bottom to the top, here is where my graph starts, and that has a y value at 2. And then it's going to keep going up forever. So we have 2 to infinity with a bracket with that 2 because this is a solid circle. Now, x and y intercepts. Where's this graph crossing on the x-axis? It doesn't. So that is none. And where is this graph crossing on the y-axis? Right here at 0, 3. So 0, 3. Then lastly, is this continuous? Again, your definition of continuous is that your graph has no gaps or holes, and we only have a solid circle, and you can trace it without lifting the pencil from the paper. Here, I can do this all in one pencil stroke. So this one is yes, continuous. All right, let's go to example 4 now. Example 4 has 3 equations, so let's do this one together. And then I want to encourage you to pause it and try to do example 5 on your own. So graph. I have 3 equations here, so I need 3 different tables. So we have y equals x plus 3. We have y equals -2. And y equals -x plus 2. All right, there are several points that we need on this graph. Where this graph is going to break is going to be where? All of these have a 1. So this graph is going to break right here where x equals 1. So that means each of these graphs need 1 in them. Now, we have 3 different ones. Only one will get a solid closed point. Which one, the first, the second, or the third, is going to get a solid closed circle? Hopefully you said the second one because that's the only one where x equals 1. So this one needs a solid circle. The rest of these ones are going to have open circles. Now, let's get some other values in these tables. For this first one here, it is not simply when x is less than 1. It is from -2 to 1. So I need to know what's happening at both of these endpoints. So the other point I'm going to put in here is at -2. Now at -2, is that one going to have an open or a closed circle? Because it's -2 is less than or equal to, this one needs a solid point right there. So let's go ahead and graph this portion of our graph. When I substitute in a 1, 1 plus 3 gives me 4. And when I plug in a -2, -2 plus 3 gives me 1. So we have 1, 4 with an open circle. And then -2, 1 with a nice bold closed point. So now let's connect these two. And if we know anything about our lines, that has a slope of 1 and an or a y-intercept at 3. So that all checks out. Okay, so now we know what's happening to the left of this, and in fact, we have nothing that's happening before -2. This is where my graph starts. So now let's go to this next one here. When x equals -1, my y simply equals -2. So at the point 1, -2, nice big bold point right there. And that is it. Because it's only when x equals 1, it's just this one point. If I can find, and I can't, here it is. On this first sheet that we did, when I had a constant, it was going between two numbers. So it had a little bit of a horizontal line. But because this one is only when x equals this one point, we have this one random dot on our graph. Okay, and now let's figure out what's happening. So we know what's happening to the left. We know what's happening on the line. Now let's figure out what's happening to the right. So here we have when x is greater than 1, so we have the 1 here. We need at least one other value here in this one. The next logical one would be 2. If you want to keep going, we can do 3 and 4. Those should fit on our graph, but we need at least those 2 to make our graph. So plug in our values. At 1, this is going to turn into a -1. So -1 plus 2 is 1. Plug this in. This is now a -2. So -2 plus 2 is 0. At minimum, that's what we need to graph, but we can keep going. Plug in a 3, it turns into a -3. -3 plus 2 is -1. And plug in a 4, we get -4 plus 2 is -2. So at 1, 1, we have an open circle And then we have regular points at 2, 0, 3, -1, and 4, -2. So we'll start at where this line is, or that open circle, that first point, and go through the rest of these. Okay, so here is my piecewise function. So let's answer our questions now. What is the domain? So as I go on this graph from the left to the right, my leastmost, my furthest most, my leftmost point is right here at x equals -2. It's got a solid point. So that's going to be bracket -2. I have x values all through that line. On this line here, I still have an x value. And then it's going to pick up and it's going to keep going all the way to infinity. So even though we have a lot of breaks going on, nothing is breaking on that x when we start at -2. Now my range. As I go from the bottom to the top, my lowest y value is this arrow right here. So that is -infinity, and then as we go up, right here, I have 2 y values, and that's okay. I at least have 1 y value, so we're not breaking. I keep going. Here, I at least have 1 y value. We don't have a y value here because we have an open circle, but I do have a y value here of 1. So there's no break. We keep going up, and then it ends right here at 4. And because this is an open circle, parentheses. So my range here is -infinity to 4. So again, here we have 2 y values, and here I have at least 1 y value, so no break. Now intercepts. X-intercept first. Where is this crossing my x-axis? Right here at 2, 0. And then my y-intercept, where is it crossing this y-axis? Right here at 0, 3. And then lastly, is this continuous? Can I draw this graph without picking up my pencil? And the answer is no. I would draw this, pick it up, draw this, pick it up, and plot this. So this is not continuous. Okay, I encourage you to pause the video and try to do example 5, because it's now going to be the 4th example that we're going to go over. We have now done 2 together, and I've walked you through 1. I'm going to walk you through 5, but pause the video and try your best to get as far as you can and do as much as you can. It helps you figure out where are you getting stuck. Okay, I hope you have had a chance to pause your video. So here is example 5. This time our graph is breaking at 0. We have when x is less than 0, when x equals 0, and when x is greater than 0. So my break right here is at x equals 0. So all 3 of these graphs have 0 to begin with. We have a closed circle at this middle one because that's where x equals 0. The rest don't equal 0, so nice open circles. So then you plug in 0, 0, 0 squared is 0. Then we need at least one other of when x is less than 0. The next logical one is 1. Now, because this is a quadratic, I definitely recommend doing another one to get a better shape of this graph, but you don't have to. But I did do -2. So when you plug in -1, you're plugging that in with parentheses. So -1 squared is -1 times -1, which is positive. When you plug in -2, you're plugging that in with parentheses. So -2 times -2 is +4. So we have an open circle at 0, 0, then regular points at -1, 1, and -2, 2, and there is that curved U shape. The other side would curve up over here. So we're just talking about this side of that curve. Then when x is 0, my y is -3. So I have this random point down here. And then here we have when x is greater than 0. So we need to know what's happening on that break. But then the next logical one right here is 1. You can do 2, 3, 4, and so on. They're not going to fit on the graph, but you can do more points to get a better accurate graph, but you need at least 2. So when you plug in 0, we have 0 plus 3 is 3. When I plug in 1, we have 2 plus 3 is 5. So open circle at 0, 3, 1, 5, and we start from that point and go through the rest of it. So here is our graph. So if you messed up on anything, hopefully that clarifies what you did wrong. If you did not do that on your own, I recommend you at least pause the video and try to do part B, C, and D on your own. Okay, I hope you pause the video. So let's continue on. The domain, as we go from left to right, we start with arrows, so that's -infinity. We have an x value at -2, -1, and 0. At 0, I don't have a point here, but I do have a point right here where x equals 0. So there's not a break, and then it picks up right here. And now it's going to keep going on forever. So the domain is -infinity to infinity. The range, as you go from the bottom to the top, the first thing we hit is this random point at -3. So at -3, you're going to put that with your fancy squiggly brackets of -3. When you have just a one number, you're going to put them in your fancy squiggly brackets. So we have -3 is the only point right there on that y. And then it's going to jump up and pick up right here at 0. So we're going to start at 0, parenthesis, because it's an open circle. And as we go up, we don't have 2 points at 3 because this one's not included, but everything above 3, we now have 2 y values, and that's okay. And they're going to keep going up forever. So my range is -3, again, in squiggly fancy brackets, the union 0 to infinity. Now, x and y intercepts. I'm actually messed up a little bit. Your x-intercept is where is this graph crossing on that x-axis right here. And it's tempting to say right here 0, 0, which is exactly what I did. But because this is an open circle right here, that point is not actually included. And so here, we actually have none. We have no x-intercepts. Okay, because this is an open circle. So then y-intercept, where is this crossing? It's again tempting to say at 0, 3, 0, 0, and 0, -3, but these two here are open circles, they're not included. So my only intercept, and specifically a y-intercept, is right here at 0, 3. So I wrote these and crossed them out to show you it's tempting to say it, but those are not included because they are open circles, they're not included on that graph. And then, is this continuous? Can you draw this without lifting your pencil? No. You would have to plot this, lift your pencil, graph this, lift your pencil, graph this. So this is not continuous.